Hello, and welcome to another topic in chemistry as we continue to understand more about formulas and naming of different kinds of compounds. We have one topic today that is a specific type of compound called acids. And so we're going to learn so here's our essential question for today. How do I write the formula and the names for acid compounds? It turns out that there's still patterns and there's still rules, but these are a little bit different. So we do have to kind of separate them and talk a little bit more specifically about acid compounds, more specifically than just an ionic compound or a molecular compound. So go ahead and set up your focus note page, our topics, put the date that you're taking these notes, and set up your EQ so you guide your learning for today. So yes, another set of rules. And the reason we need another set of rules is because acids are kind of special. Here are acids that we will see commonly, the four types of acids, like it says, that you will need to know how to write the formulas for, how to write the names for. So take a few moments right now, and what do you notice about this? What do you notice about all the formulas? What do you notice about all the names? Any patterns, any things you might notice? Go ahead and just kind of think ahead about what kinds of things we might talk about. All right. So the thing you might notice is that all formulas start with H and all names end in acid. So that's something that's nice. So if you're like, well, how am I supposed to know when to use these acid rules? We haven't learned about acids. Well, this is how you'll know. If I give you a formula that starts with H, you know that you're going to use this set of rules. If I give you a name that literally has the word acid in it, you know that we're dealing with this new set of rules. The only exception to this for now would be water, H2O, but that is one that I hope you would recognize, like, oh yeah, that's just water, that's not an acid. Okay? So the reason we need a new set of rules is because the acids kind of act like ionic bonds because you are balancing charges, but you're also dealing with covalent bonding because all of the elements involved are nonmetals. And so that's why it doesn't really perfectly match either of our rules sets that we already have. And so that's why we need another set of rules. All right, go ahead and do a level 1 question already. A great one would be list what element do all acids start with? That'd be a great level 1 question. Comes right from our notes. Okay, let's get into it. So let's talk about the pattern when you're writing the formula. So you're given a name such as hydrochloric acid. Hydrochloric acid. You might know this is the acid that's in your stomach. So what do you do to write the formula if you're given the name? Well, the first thing you know is you say, oh, okay, the name has acid in it. Acids always start with H, and we remember that H's have a +1 charge. So that's just our definition of acid, that they start with H +1s. And we'll learn more about acids later in chemistry, but for now, know that that's the definition of acids. So for sure, when you're writing the formula, the first thing you're going to write down is H +1. But then we got to figure out what it's bonding to. So if it says hydro, that means that there are no oxygens in the anion part of the formula. So the cation is the positive part. We already have that. The anion is whatever is negative, balancing that positive charge. So because it says hydro here, there's no oxygens. So that means you're going to find the root of the word. So hydrochloric, the root would be kind of like the middle part of it. And what element sounds closest to that? So in our case, it's chlor. That's the root of this word. Hydro means it's not chlor with something else like oxygen. It's just chlor or something. So what element sounds like chlor? Chlorine. So chlor sounds like chlorine. So Cl with a -1 charge is the anion part of this formula. And then we balance the H plus with whichever the negative charge is. So if H is a +1, Cl is a -1, perfect match, the formula would be HCl. Let's try one more example. Hydrosulfic acid. The acid means we are starting with an H+, so we would write down an H+. Hydro means there's no oxygens in the negative part of this formula. So we find the root, which would be sulf, and we find what element sounds kind of like sulf. You look on your periodic table, sulfur kind of sounds like that. So then we find the symbol and charge. So it'd be S for symbol, charge would be -2. That has to balance the H +1. So then H +1, S -2, this would mean 2 hydrogens to balance out that -2 charge. So H2S is the formula. And again, the reason it's just sulfur instead of a polyatomic ion with sulfur and oxygen is because of that prefix hydro. So the name hydrochloric acid matches just HCl, hydrosulfic acid matches H2S. So that's the pattern for formulas if you're dealing with just a hydrogen and an element. Okay, but what if you don't have just hydrogen in an element? So what if you don't have that hydro? So what if you're given a name like sulfuric acid. So sulfuric acid. Okay. Well, again, the acid part of the name tells you that you're dealing with H plus. That's just the definition of acid. So the first part of our formula with this name would be H plus 1. Since you do not have the prefix hydro, that means there is oxygen in the anion spot. And again, the anion is the negative part that's balancing out this positive charge on the hydrogen. So what we're going to do is we're going to find the root of the word. In this case, it'd be sulfur. And you find the polyatomic ion. And again, I know it says peach sheet. It used to be peach when I handed it out. So it's the ion guide sheet. So what polyatomic ion ends in 8 and starts with sulf? Okay, well, that would be sulfate. So sulfur is closest to sulfate because we always use the 8 ending. If you learn more chemistry, you'll learn about other endings. But for now, just know we're always using that. So it's not sulfite. It's not bisulfite. It's nothing else. It's just the 8 ending. So sulfur from the name tells us to find sulfate on the ion guide sheet, and it would be SO4 with a -2. All right. And then we do our same chemistry math like we've done for other places. Balance the H plus with whichever negative charge we have. So if this is a +1 and that's a -2, I need 2 of these, which will be a +2 to balance the -2. The formula becomes H2SO4, sulfuric acid. So again, the reason it's SO4 instead of just sulfur is because of the name. Hydro means no O. Hydro, no O. Without the hydro, that means there is oxygen. So then that's why it was the polyatomic ion sulfate. And the reason it was SO4 sulfate instead of some other SO compound is because we're learning the rules where 8 is the ending always. There's other rules for the other endings, but we're not going to worry about that for this pre-AP class. Let's try another one. How about phosphoric acid? All right. Well, acid tells me I start with H plus 1. There's no hydro, so that means this is going to be a polyatomic ion that sounds like phosphor, but then I need 8, so phosphate. So find on the ion guide sheet phosphate, which is PO4 with a -3 charge. So H plus 1 balancing that -3 means I would need 3 hydrogens to balance the phosphate. So H plus 1, PO4 -3. The H plus is because of acid. The PO4 -3 is because of the root of the word and the 8 ending, PO4 -3. I need 3 +1s to balance out the -3. And so H3PO4. And again, the negative part is always the 8 ending because that's the rules we are learning. There's other acid rules for other acid formulas. We're just not learning about those in our pre-AP class. All right. Okay, hopefully you're able to see some of those patterns. And even though it's another set of rules, you're like, oh, okay, that kind of matches some other patterns that we've seen before. So go ahead and do a level 2 kind of question so far. You can get cue words from that Costa question guide that's on Schoology. Come up with a good level 2 question. Go ahead and pause the video, start it when you're ready. All right, well then now the last part is we got to do the opposite. So what if you're given a formula and you're trying to find the name of the acid? So let's say you're given a formula like this, HNO3. Well, the first thing you need to recognize is that this starts with H. So you're not trying to name this hydrogen nitrate or hydronitro oxide. No. You got to follow the acid rules because this is an acid compound. We see that there is oxygen, so that tells us we will not put hydro in the name, because remember, hydro, no O. So because there is oxygens in the name, there will not be hydro, okay? So then we take off the H. Whatever is left is on the ion guide sheet. So again, that peach sheet is really the ion guide sheet. So take off the H. NO3 is on the ion guide sheet. NO3 is called nitrate. And then we take off the 8 and we put ic acid. That's the naming rule. It always ends in that ic acid for the rules that we're learning. There are other endings, but again, we're not learning those rules right now. But just know that you might see that other places, like nitrous acid or something like that. But for now, we're just learning the rules. So 8 endings on the ion guide sheet and in ic acid when they're turning into acid names. Okay, so let's try to put that all together. So nitrate becomes nitric acid, and that's it. We don't put anything else on the name because the acid represents the H and the NO3 is represented by the nitric part. All right, let's try another example. HC2H3O2. Okay, so it starts with an H, so we know we're using the acid rules. There is oxygen, so we're not going to put hydro in the name. Take off the H, so if I get rid of this part, C2H3O2, that is on the ion guide sheet. Go ahead and find it. Can you find it quick? acetate is what it's called. So I'm going to take off the ate and put ic acid. So instead of acetate, I'm going to say acetic acid would be the name of it. Okay, so here's what we just did. The H means acid. There is oxygen. So find the ate ending on the ion guide sheet. No hydro in the name because of the oxygen. So blah, 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 blah. Acetic acid. Because of acetate changes to ic acid. The acid tells us it starts with an H. The acetic part tells us it was C2H3O2 from the ion guide sheet. All right, let's try one of them that doesn't have oxygen. So what if you're given this formula, HCl? Now, you might already know what this name is, but let's figure out why it's called that. So again, it starts with an H. So we know that we're using the acid rules. This is not hydrogen chloride, right? That's not what it would be because it's a different kind of compound. So acid rules. There's no oxygen, so that means we will put hydro in the name of it. Hydro is a prefix, so it's the first thing you would write down, hydro. Then take off the H. Whatever is left, find that element name. So I find this element, chlorine, so Cl for chlorine, and then you take the first syllable and you add ic acid with hydro in front. So hydrochloric acid. Put all of that together. So the hydro is because there's no oxygen. The chlor is for chlorine. The ic acid is because it's an acid compound. We know that because of the H. Let's try another one, H2S. Okay, so it starts with an H, so we know we're going to use the acid rules. There's no oxygen, so we will put hydro. So hydro comes first. We take off the hydrogen and find S, which is the element sulfur. Take the first syllable, sulf, and put ic acid. So you might say hydrosulfic acid, and I wouldn't mark it wrong, but it turns out that they use more than the first syllable for this one. They use both of them. It happens to be hydrosulfic or hydrosulfuric. You'll see both of them, but this will follow our rules. So hydro, because there's no oxygens, sulf for sulfur, ic acid, because it's a hydrogen acid compound. It starts with hydrogen. Okay, hopefully those patterns start to make sense. You can always go back and look at this again if you need to, if I was going too fast. But I think you're ready for a level 3 type of question. Find a question starter, a great example on your Costa question guide. Go ahead and finish off your Costa question notes and then come on back to the video. All right, so let's see if you got it. So go ahead and on your output page in your notebook, would you try these examples? So name the following. So HF, what would be its name? And HClO3, what would be its name? And then write the formula for hydrobromic acid and carbonic acid. Go ahead and try them. And then when you think you've got an answer, I'm going to go through the answers on the next page. So we're going to see if you get it. So did you get it? Go ahead and try these examples. Pause the video. All right, come on back. Let's see if you got it. So let's check the answers. So the answers will be in green here. So HF, there's no oxygen, so we need hydro. Fluor for fluorine, and then the ic acid because it's an acid, so hydrofluoric acid. HClO3, ClO3 is on the ion guide sheet. It's called chlorate. You chop off the ending and say chloric acid. Why is it ic acid? Because it starts with an H compound. Why is there no hydro? Because there's oxygens in the formula. So that's kind of a review of our notes so far. Now let's write the formula one. So if you're given hydrobromic acid, hydro means there's no oxygens. Brome for bromine. Bromine is a -1, so you balance it with one H. So HBr is all you need. Carbonic acid, well, this does not have hydro, which means you do have oxygen. So you find on your ion guide sheet what ate ending sounds like carbon. All right, well, there's a carbonate. Carbonate is CO3, but it has a -2 charge. So I need 2 hydrogens to balance that -2 charge on carbonate, carbonic acid. All right, hopefully that made sense. If not, there's some practice on the unit practice problems. You can come to office hours just to practice this a little bit more. But go ahead and do your summary for today to summarize how do I write the names and formulas for acids. And when you're done with that, that brings us to the end of our 5th day of Unit 2. Finish any Costa questions, finish your summary if you didn't already do it. And then remember, you have that naming or formula and naming practice assignment. It's technically not due depending on what hour you have. It's not due today, but but it's due before your next class. So if you're in hours 1 and 3, this is due on Friday. If you're in hour 4, it's due on Monday. So before your next class, you should turn in this assignment. There are a couple unit practice problems that go for today's notes. So if you want a little bit more practice and being able to check your answers, see if you understand it, do those unit practice problems. But otherwise, there's no new assignment today. Of course, you can always come to my office hours if you have questions. Otherwise, I'll see you at our next Zoom. Thanks for listening. Bye.